at my end, just to be on safer side. Okay, my recording, yeah, okay, good. All right, so after a week, like again, we are going to resume same topic, IP addressing. And before I jump to the next discussion, next, in fact, presentation file, let's have a very quick recap, review of the previous like class. So if you remember, then we like discuss few very important points, and let me quickly write it down here. Okay, so we first, like initially, we talked about MAC address, media access control, MAC address, pre-assigned hardware address, right? So MAC address is hardware address, and that is why like we also use another term to describe MAC address, and that is physical address. But MAC address is pre-assigned 48 bits in binary, hexadecimal representation, and then I started with IP address. And IP address is basically not a hardware address, a software address. Software address, because the IP address like is very much part of your TCP/IP protocol configuration. So IP address is not hardware address, software address, or even we can use the term logical address. Okay. Then in IP address, if you remember, then we talked about different classes of IPs, and total there are 5 classes, 4 and 5. Class A, Class B, Class C, Class D, and Class E. Total there are 5 different classes, right? Class D, E is like reserved for research purpose, so not for use. Class D for multicast communication or multicast routing, and multicast is like one to many communication, one to many, one sender and multiple receivers, right? So we mainly talked about class A, B, and C addresses, and they are meant to be used in unicast communication or unicast routing. Unicast, and there's another type of communication, that is broadcast. So as there is no reserved class for that, for the broadcast, the last address of any network address, either class A, class B, or class C, reserved for broadcasting purpose. And broadcast means one to all. One to all. So broadcast and multicast are like very similar to each other, because multicast is also a type of broadcast, one to many, like for group of host devices, broadcast is like one to all. So one to all is broadcast address. But over the internet, broadcast address is never permitted. Broadcasting is never permitted. Broadcasting is only for a LAN segment, a segment, network segment only. Over internet, no, not allowed. Broadcast is not allowed. Unicast and multicast both are allowed. So from routing perspective, we always talk about unicast routing or multicast routing. And we'll understand like what is routing in upcoming classes. So we will understand both. But from routing perspective, either unicast routing or multicast routing. Broadcast is something like one to all and limited to a LAN segment, local area network only. And as there is no reserved category, there is no reserved class for broadcast. Last IP address of any network is used as a broadcast address. So we have total 5 different classes, right? Class A, B, C, D, and E. A, B, C for unicast. And then next we like also discuss about like identifying class of IP address. So if you remember, so for identification, you will have to remember value in the first octet. If the first octet has any value from 1 to 126, means class A address, right? To identify class, we don't have to look at octet number 2, 3, and 4, right? Only octet number 1, first octet, this one. So any number between 1 to 126 means class A address. And then class B, any value from 128 to 191 in the first octet means class B address. Any number, any value between 128 to 191. Class C, again the first octet, if any value between 192 to 223 means class C. So class C is 192 to 223. And second octet, third octet, fourth octet, irrespective of the class, second, third, and fourth octet can have any value between 0 to 255. 0 to 255, irrespective of the class. But in class A, first octet represents network portion, network ID. In class B, initial 2 octet, and in class C, initial 3 octet represent network portion. And if you remember, so we talked about network and host portion or network and host ID in IP address, right? So if you like, we understand that the first octet here is to define network portion, network identification, and this is again network ID up to here. And in class A, only the first octet, and in class C, this entire 3 octets network ID, right? Up to here, this one and this one. So like so basically in class A, B, and C, in all 3 classes, right? There is predefined value in the first octet. In class A, any value between 1 to 126 means class A, any value between 128 to 191, class B, 192 to 223 is class C, right? So whenever, and why is so important, like understanding or remembering like first octet value range and network and host bits, because if like if you remember, then we just let me quickly do same again here. So if here there is a switch and maybe a couple of computers here, one and maybe another one, and then the third one, maybe fourth one. There are 4 computers. Physical connectivity, yes, they are connected, but this centralized device, switch, right, all connected here. That's why. Okay, now after doing physical connectivity, if you remember, then we talked about IP configuration, right? IP configuration. IP configuration means bare minimum assigning IP address, logical address to all 4 end devices or host devices, right? IP configuration. So is there any question from someone? Sure, I will give record permission. I think you have, oh, here, okay. Yeah. Rashid, I have given you record permission, so now you can start recording. Yeah, started off. Good. All right. So we then talked about IP configuration, that once you have finished doing physical connectivity, right? Then the next step is what? IP configuration. End devices, host devices, they all need to have a unique IP address, right? And without IP address, devices cannot be located on the network segment. Okay. Now, even though like they all have one address, pre-assigned address, that is MAC address or hardware address, right? Hardware or MAC address pre-assigned to the interface, but protocol that we are using, TCP/IP, if like there's no proper configuration, so this protocol will never like communicate. I mean, like no way to communicate with any host device on the LAN segment, right? Means all four end devices should have proper IP configuration, right? Now, do either like statically, manually, that's up to you, or maybe dynamic. No matter like whether you are doing manual configuration or automatic configuration, but they all should have proper configuration, IP configuration, IP address, right? In a small network wherein like there are 10, 20, 30 computers, even you can do configuration manually, static configuration. In large enterprise network, there are 100, 200, 500,000 devices, not feasible, right? Manual configuration, not feasible, not very scalable. So what we do, we go with this another way of doing configuration known as dynamic. Dynamic means automatic. Automatic. And again, here there is one protocol, right? Used here, dynamic host configuration protocol. So what we do then, we configure one of the end device, either maybe a computer, or even this device can also be configured, or maybe another network device as a DSCP server, right? And that device means the DSCP server would be responsible for providing configuration automatically. But that's not like we are going to understand for now. We'll understand this later on, right? DSCP configuration. But initially, we want to understand IP addressing, not the way like how it is configured. Like so, initially, yes, we are going to stick like with this static configuration, manual configuration. In later part, later section of the training, of course, after 3, 4, 5 classes, I will show you how to configure a computer or maybe a device, network device as a DSCP server to automate IP configuration process. But that's different discussion altogether, right? Now, so either you are doing a static configuration or automatic configuration. They all need to have a logical address, IP address, right? And today we'll understand like out of 3 different classes, class A, B, and C, which class we should use in our internal network, whether we should go with class A, class B, and class C. That's another important point. And once, like, let's say you have picked up maybe class C address, right? Let's say you have assigned 192.168.50.1 IP address to one of the computer. So first thing, identifying class, right? And then understanding network portion, network bits. So first thing first, and the first is what? Identifying class. And how to identify IP address class? Looking at the first octet. Okay, even if you, let's say you have written IP address here 168.200.1, right? And if you ask me like the class of this IP address, if you ask me like to which class this IP address belongs to, so of course I cannot answer this question. No answer, right? No one can answer this question. No one can tell the class of this IP address. Why? Because first octet is not known. We don't care about the second, third, and fourth octet, right? For IP address classification, no, we don't care. Even if you hide the second, third, and fourth octet, if you just tell me the first octet, so yes, I'll be able to tell you the class of IP address. Okay. So if you say like, okay, IP address 125 and then any number, yes, very much I'm in a position to identify the class. Is 125 means what? Class A. So identifying class means only looking at first octet. We really don't care about second, third, and fourth octet. Okay, first octet only, right? And once class is identified, then the next point. So first point is identify the class. Second point, find out network bits, right? So since 192 means what? Class C. 192 means class C address. And in class C, initial 3 octets, this portion, what? Define network bits, represent network portion, right? And what is our objective? Objective is to put all 4 computers in one network, right? So that they can freely talk to each other, they can freely communicate with each other. That's what our objective is. Okay. And I have identified the IP address is from class C. Now, next step is assigning IP address to this machine. So, initial 3 octets should exactly match, right? Should be same in fact. And the 4th octet, the octet that define host portion should definitely be unique. So now I can take any number here, but from this range only. And even the first and the last address, both address in this class C cannot be used. Both are reserved, right? This first address to define represent entire network, and the last one is the broadcast address of that network. So even we cannot use 0 or 255. Even if I try to take 256, no way, right? It's gone beyond the range. 256 is beyond the range. Maximum value can be 255. And 255 is the last address, so cannot be used, right? And if I take here the same 1, so again, I can take that, no problem. But you understand, if source address means sender address and receiver address, both are same, so packet can never be sent. And 2 persons means 2 houses cannot in the same locality, in the same area, in the same building, cannot have same house number, right? Same here. 2 computers on the same network can never have same IP address. So even if I take 1 here, so immediately probably we will not get any error message, right? Will be accepted, applied. Later on, you'll see error message on the screen like IP conflict error message, right? IP address conflict, because 2 computers cannot have identically same address. But yes, I can assign 40 here, this machine 50 or 60 or something. So that's the way how we assign IP address. But still the big question is still unanswered, right? I have not answered that question till now. What should be the criteria? How I should, let's say I'm very new to this IP addressing. I don't know like different classes. So how I can pick my class? I mean like whether I should use class A, B, or C. Which class of address I should use in my network? That's a big question. And before I just explain that, like the criteria on what basis you can select class of IP address. Another important point here is, again, I'm taking the same discussion that we had in the previous session about private and public address. So let me start from there only first. So there are two questions, which class IP I should use in my network, right? A big question. I'll answer this. Hang in there. And if you remember, then we talked about this IP addresses. Like there are two types of IP addresses. So this question is still unanswered, right? I'll answer this question. But IP addresses, like we have public IPs and we have private IPs in each class, right? Either A, B, or C, right? There are private and public addresses. Okay, so public IPs means not free to use. As I already discussed this point, they need to be globally unique. We are not free to use, right? Globally unique, must be provided by internet authorities or your service provider authorities, right? Private IPs, free to use. You don't have to ask anyone, right? They need to be locally unique only. Why? Because like non-technical term is like non-routable over the internet. For now, you can understand. For now, you can understand non-routable over the internet means like can't be used over internet, right? We cannot like communicate over the internet by using these IPs. Private IPs, free to use, locally unique. Now, to let's just assume that I've decided to go with class B address, right? Because as we mentioned, like there are different classes, like class A, first octet means like 1 to 126, 1 to 126 first octet, right? Class B, 128 to 191, sorry, 91, 2. And then class C, 3 classes for unicast routing and 223. All right. Now, let's just assume that I decided to go with maybe class B address or class C address. So now in class B, as you can see, ranges in the first octet. In the first octet, range is what? 128 to 191. 128 to 191. Now, can I take any value then? I mean, like here, there are 4 computers, right? I decided to use class B address in my network, in LAN network, my private network. LAN means private network, private, not internet, right? Internet is what? Public network, right? Now, can I use any address then to this machine? Or like, let's say 130.150.1.1. Yes, I can use, but not recommended, and this may create a problem, right? This may create problem, and I will explain how. But yes, I can use, even though like it's very unethical. I mean, like in class B, if I am free to use any IP address, so does that make sense? Like private and public IP? No, there has to be certain reserved range for this private IP for internal network, because I'm not sure like whether this IP is already assigned to any like yahoo.com or maybe google.com or facebook.com or anywhere. I'm not sure. I don't have any idea, right? I don't have any idea whether this IP address is already in use or not, right? So it's very, like unprofessional networking, in fact, assigning any address. No, we have to be 100% sure that the IP that I'm going to assign is not assigned to any internet-based network or servers or websites or URLs, right? I have to be 100% sure. But how we can be sure? We don't have internet directories. We don't have list of all IPs assigned to different networks over the internet. No, I don't have list. So how I can be sure? I mean, like, if I'm going to assign any IP address, so how I can be sure, like, whether this IP is already assigned to any net computer or not over the internet? Even though I'm going to assign this into my local machine, so doesn't make much sense because it's not connected to internet in any way. No problem whatsoever. But it's still better, like, if I can be 100% sure that the IP address is not assigned it to anywhere. So for this, there is one internet-based organization, right? Internet-based organization, and known as ITF, ITF, IETF. Organization is an internet-based organization, Internet Engineering, Task Force, right? What they have, and if you want to read more about this, then you can open the site like www.ietf.org, right? You can read more about this organization. And there is another organization also like dealing in the same like global organization, and name is INA, Internet Assigned Numbers Authority. And if you want to read more about this, then just you can visit this ina.org. These two, right, have like done a very good job, right? And what job it is? So what they have done in class A, class B, and class C, some addresses are not assigned over the internet. They are absolutely reserved. In class A, any IP starting from 10 is what? Private IP address, right? Private IP range. Private IP addresses means not assigned to, not used over the internet. Addresses not used over the internet, reserved for internal private network use, right? Any IP starting from class A and in class B from 172.16. Any address to 172.31. Any address. And in class C is any address starting with this, right? These three addresses, not three addresses, basically, three classes, IPs reserved. You will not find these addresses assigned to any server, any device over the internet, right? You'll never find this. You will not find IPs from this range, or maybe starting with this or 10 over the internet. They're absolutely for private network purpose only, private IPs. So now, if I have decided to go with class B address, right? I decided to go with class B address in my network. So definitely, I should not use any address. No, what I should use, if I decided to go with class B, so even class B has very wider range, any value from 128 to 191 in the first octet. But to be on safer side, to be 100% sure that the IP that I'm going to assign is unique, not used anywhere, not used over the internet, what I should use, I should assign IP address from this range only, either 172.16 and then any value, or maybe 172.17 and then any value, 18, and the last one is 31, right? So if I assign IP address from this range, means it's absolutely, completely, totally private IP, not used over the internet. So to be on safer side, you should always use IPs from this range only, right? From 10 in class A, class B 172.16 to any value between this, and class C is 192.168, right? And now let me take another scenario. Let's say you have a, let's say you have a server here, right? A computer, maybe maybe in your home network, no problem whatsoever. So let me quickly take this. Let's say you have a server here and hosted application software on the server, right? Just a website maybe, and you want that this server, the website hosted running on this machine, should be accessible globally from anywhere, right? From anywhere, anyone from over the internet, like this server should be accessible, right? Anyone, like let's say a person sitting in Middle East, maybe in East Africa, in maybe US East or Asia, anywhere, right? They all should be able to access the website hosted on this server. And this server can be physically anywhere. I mean, like if you want to put this server in your home network, yes, that's possible. Maybe you want to put this in data center, maybe some co-location, maybe in cloud, Azure, AWS, Google Cloud, you put this server anywhere. From security perspective, I will discuss later on. I assume like you all are very new to this networking field, so I'm not putting like bringing in here like a lot of technical terminologies, right? Because directly exposing server over the internet means like will take not less than 5 to 7 minutes, and your server will get hacked, right? So that's not the best way. Like it's not designing the best design to expose your server this way. You cannot afford to do all this, right? But that's something a separate discussion. I will discuss that like in security section. What is the best way to publish application over the internet, like where your firewall should be, how to protect this server, because if directly your server is exposed to the internet, so probably in next 5 to 7 minutes your server will be down, right? So but that's something different. So I'm not going to talk the placement of servers, security stuff. No, like at least today, no, I'm not going to talk about those stuff. Now, so your application or website is hosted on the server, and your objective is to make application software website available to all users globally. Now, you cannot assign private IP address to this server now. If you think, okay, I'm going to assign this address 172.16.0.1, yes, you can assign. You can assign this address, no problem, right? For assignment point of view, there is no problem. You can assign, but what is the problem? Problem is, like, access, how like this server would be accessible? No one would be able to access your server. Why? Because IP is what? IP is private IP address. Private IP means not recognized over the internet. In technical term, I would say IP is non-routable over the internet. Means internet devices like the routers and some other networking devices, like they really don't know about private IPs. No way to route packet to this server. Means your server, your website, your application wouldn't be accessible, right? So how to make this server accessible to everyone, right? So for that, your server should have public IP address, right? Public IP address. What is public IP address? IP address recognized, routable, valid over the internet. And as I mentioned before in previous class also, public IP means globally unique, right? Globally unique address. So now you understand the requirement. Requirement here is what? Assigning public IP address. But how I can get public IP address from where? Like I should get this IP. I don't have any idea about like public IP. I mean like whether IP is globally unique, how I can ensure that, right? I don't have much knowledge. I don't have the dictionary database. I mean, how I can ensure like the IP that I'm going to assign to this server is globally unique. No one like over the internet is using the same IP. Of course, I cannot be sure. So how I can get the public IP? So for you as a customer, right, you will have to approach where? To your internet service provider. Internet service provider, cable modem provider, your broadband internet provider, FTTH, like whoever is providing internet, right? You can approach internet service provider. You can ask your service provider that I need to have a static public IP address, right? And your service provider might charge some extra money, right? For that extra dollar for static IP address. You'll have to pay that regularly. Every month you'll have to pay, right? If your billing is monthly or annual billing, you'll have to pay that IP. So let's say your internet service provider has given a public IP address like this. You can assign this IP address to the server. However, in real environment, we never do that, right? We never provide IP address directly to the server. We put this server behind a network device, behind a firewall device. For security reason, I will talk about like those security later on. But now, IP address provided by internet service provider. Internet service provider means this IP address is definitely would be globally unique. Now we are 100% sure that the IP address is not used anywhere, right? No one over the internet is using same IP address. But how this internet service provider, providers do that? How they provide IP address public? Even they're asking money, right? Nothing comes free. But how do they provide? Because again, it's a very uphill task, a very complicated process. I mean, like maintaining like database of IPs, public IPs. So that's where these two organizations, internet-based organizations, comes into the picture. And for IP assignment, there is one global body, INA, right? As I mentioned, you can read about this, INA.org, right? You can open your website, you can read about this organization. So INA is the internet like authority mainly responsible for distributing, assigning, maintaining uniqueness of IPs, right? And everything like taken care by this organization, INA. Is a global body. Now, alone INA cannot handle like so much pressure, so much work. So under this INA, Internet Assigned Numbers Authorities, there are 5 regional registries, 5, right? Known as RR, regional registries. There are also internet service provider, big service provider, 1, 2, 3, 4, 5, right? For Asia region, there is another authority, APNIC, right? ARIN is for American region, AfriNet is like for the Africa, Europe, and Australia. They all are what? Regional registries, right? So INA has provided pool of public IPs to ARIN, to APNIC, to AfriNet, Australia, and Europe, right? And maintain database. Now this APNIC, if I take the example of this APNIC, so in Asia, in fact, there are so many countries, right? So now here there are country level or specific internet authorities, right? Different authorities, like IRIN is one authority here operating in India. It's a country based. So when I'm putting up in India, in any city, if I need to have public IP, so directly I'm not going to approach IRIN. No, sorry, this INA. No, I cannot do that, right? I'm not going to approach this. I'm sorry. Oops. Okay, I'm not going to approach INA. No. If I'm in India, I'll approach my country authority, internet authority, like this IRIN. I'll approach IRIN, maybe the local internet service provider, because just below this, beneath IRIN, there are local service providers, right? It's a complete structure. And why is all like INA, this, to maintain uniqueness of IP, global uniqueness, as I mentioned, IPs need to be globally unique over the internet. So we are not free to use any IP address. I mean, like public IP address. We are free to use any address from private range, right? From private range. So INA is a global body, as I mentioned. APNIC is like for Asia. So even if you want to read about this, I think apnic.net is the organization name. So you can read about all this. INA, global this body, and INA is doing a lot of other job also. I mean, like this domain name and some other stuff, even like number resources and IP address. AS number you will understand later on. So it's too early to understand autonomous system number for now. I will explain that in routing section. But see here, like these are registries, in fact, right? Regional registries, 5 registries. Afrinic for Africa region, Asia, Pacific, America, Canada, and other region, Caribbean islands. LATNIC for Latin American, and RIPE NNCs for Europe, Middle East, and Central Asia. So there are different regional registries, and IPv6 is like the latest version of IP address, right? Since we are running out of IP, so this IP address 6 is also nowadays being used. So currently there are 2 types of IPs, right? IP version 4 and 6, and how we are studying IP version 4. So if you want to read about any organization like further in detail, so you can go to maybe this APNIC is like for Asia. So it's a regional internet registry administering IP addresses for the Asia Pacific, right? So responsible for maintaining uniqueness of IPs in Asia region. And you understand, like if there is no authority, there is no organizations. So how global uniqueness of IP can be maintained? Who would be responsible to provide IPs, right? And it's not free of cost, right? It's a paid, and you are not buying, in fact, IPs permanently. No, we take IPs on lease, right? On lease, right? Renewal basis, you'll have to pay like IP price. In fact, you can even like APNIC, like yes, can be a risk. If you need a very big pool of IP, then even you can approach big service provider, these authorities. If you need 1, 2, 3, 4, 5 IPs, no, like they are not going to entertain you, right? These are regional registries. Okay, and even you can see like my IP address is shown here, like your IPv4 address is my IP address. So and at this time, no one else like would be using this IP address. It's globally unique address, right? So I hope you understand this point, private and public. Any question, guys, so far? So you can ask like if you whether you understood this whole concept or not. Mainly like previously, of course, like I tried to recap the previous class, but it's a good concept here, private and public IPs. So I hope you all understand. But if any question, any doubt, anything, if you want to clarify, you have any doubt in your mind, so yes, you are free to ask. You can interrupt me anytime, no problem, right? Even you can interrupt in between also. You don't have to wait like for my pause. Like if I will take a pause, then you'll ask a question. You can ask a question anytime, anytime you can interrupt me, no problem. So it's like the private and public IP concept, right? So coming back to this, if my objective is to assign IP address to all four computers, right? And really, I want to put all four computers in a same network, in a same network. I don't want to create multiple networks here, okay? Because for different networks, then routing comes in here, and then we need a lot of other like configuration, protocols, knowledge, other stuff that we would cover later on. So if my objective is to put all four computers in a single network, right? So for logical address, software address, IP address, I'll have to first pick a class, whether class A, B, or C. And as I said, like I will answer this question. But after deciding, after choosing class, let's say I have chosen class C network. So now I am not free to assign any IP address, even though I can technically, right? Because computers are not connected over the internet. So even if I assign any IP address, let's say this IP address, no problem. Machine is completely isolated, not connected with internet. Is there any issue? No. Yes, if if I connect my network to the internet, and let's say over the internet, if another computer has same IP address, and that can be possible, right? Because I'm not sure. And if I try to communicate with this computer, so even like that wouldn't be possible, right? Because sender and receiver, they both are same, then you understand like there is no way to get that packet routed to the destination. That is why it's like to be on safer side, you should always assign private IPs, right? Even whether like your network is exposed, connected with the internet, not connected, even though like when packet gets routed over the internet, so if you remember, so in previous session we discussed about the translation, IP address get translated, but the question is, even the if the source and destination IP both are same, then packet would never hit any network device. Even the packet will not come out of this computer even, because if I just run any command, let's say ping command same, and this address, so how does this computer know like whether packet need to be sent across the network or locally? Obviously, the same IP is assigned to the computer, so it will just test like this, ping locally only. Packet would never be forwarded to the gateway. Technical term would be gateway, right? So, conclusion, summarization is what? First, decide what class of IP you are going to use. Understand network bits, network ID of the class, and also remember range. Range means private IP range. This one. You don't have to remember public IPs, right? Because private means like not used over the internet. We are 100% sure, right? Because ITF and INA, they have decided not to use these addresses over the internet so that customers can use these IPs in internal network. Got it? Good so far, guys? Any question, any doubt based on private and public IPs? Because now I will jump to this portion now. Which class IP I should use in my network, right? That's another question I need to answer. So I'll jump to this portion now. So let me. So again, the same question, right? Same question. And just to give you a basic idea first, like before I like give very technical explanation. So before just jumping to the technical explanation, let me give you a very quick and easy way of explanation. Easy explanation, I mean. Okay, so as we have understood now, like there are three different classes: class A, class B, class C. There are three different classes of IPs for unicast routing, right? I'm not discussing multicast routing. Multicast routing is different. And let us assume we also understand like the private IP ranges in different classes. We understand that, but which class, right? A, B, or C, and why? Now let me take one example. Let's say you have 300 end hosts or computers Host means like everything, computers or maybe your mobile phone, laptop, desktop, servers, right? Total 300 devices you have, right? You have been asked to like do the networking of 300 computers. So if you remember, so in very first session, we talked about physical connectivity, right? Because in networking, the first step is what? Doing physical connectivity. You'll have to connect all 300 computers. And how we can do that? With the help of a network device known as switch, and rather switches, right? Because probably you will not find a single switch of 300 ports. So multiple switches would be required, would be needed, right? A switch here, maybe if this switch has, let's say 48 ports, so you can connect maximum 48 devices. Then from this switch to another switch, and then computers here, then another switch, maybe computers here, right? So this way we can extend network, multiple switches, and switches can have like 48 ports, 96 port, 24 ports. So this way we just do the physical cabling networking of 300 computers, okay? In switching section, I will explain all the whole concept, I mean, right? Because we would have to design network in redundant fashion, because if one switch is placed at the maybe first floor of your office building, another switch maybe a second floor and connected with single cable, and if this cable disconnected, something problem, so both end devices completely isolated with each other. So definitely we'll have to take care of redundancy also, right? So we'll have to design a redundant network, and I'll explain how to design a redundant network, but that's not like today class objective. Okay, let us assume now you have done like you have done physical networking of 300 devices, right? You have done that, you have finished that. Now the next part, TCP/IP protocol, software. You understand, like two computers without using a common language, common set of instructions, rule, they can never talk to each other, right? Because protocol is what? Protocol is very much like a language, set of rules, instructions, right? That's what a protocol is. Because if there are two persons, right, they both are within the reach, right? Maybe connected via phone, or maybe they both are in the same room, same building. But if they do not use a common language, right? So no way like they would talk to each other, they can communicate with each other. One person is speaking French, another one is Spanish. There is no way like they can never talk to each other. So for communication, not only the reachability, connectivity is required, even the common language, protocol. But we don't have to worry with protocol, because this protocol, TCP/IP, transmission control protocol and internet protocol, is what is the default protocol, default of Linux, Windows, and other platforms. You don't have to install this software, it's a program. But what we need, we would have to configure this protocol, TCP/IP, right? Means after doing physical connectivity of 300 devices, next step is what? Installing this software? No, already installed. But IP addressing, yes, required. This has to be done by the administrator. You as an engineer will do this job, IP addressing. You'll have to ensure unique IPs of all 300 computers. Do it manually, means static configuration, do it dynamically, DHCP server, it's up to you. We have both the options. If you think no, like it's not possible, like 300 computers, I'll have to move across all the 300 computers to assign IPs. It's a big task, no, not feasible, right? And then maintaining uniqueness. Yes, you can automate this whole process with the help of another protocol, DSC. Also, you practically later on, right? I mean, like not today, later on means not today, means like in upcoming classes, I will show you how to configure. But the question remains same, like, okay, like whether I will do configuration static or dynamic, but how I should decide the class, which class IP address, A, B, or C. Now, let's say I decided to go with class C. So what is the problem in class C network? In class C network, if let's say first computer, you assigned IP 192.168.1.1. Second computer, 192.168.1.2. Third computer, 192.168.1.3. And why I'm using 192.168.1 everywhere, you understand that, right? Because initial 3 octet is what? Network ID, network bits should be same. Okay, network portion should be same. So what I'm changing? The 4th octet, host portion I'm changing. 1, 2, 3. And where, up to where I can reach. So first address, like the 0 is not used, the first address is reserved, right? Network address basically. I'll be using this address later on, like in routing and all that. And last address is also not used. And what would be the last address? So this way, I can assign now, let's say 254 and then 255. No, I cannot. It's reserved. 256, no. 257, no. Even like the range is 0 to 255. And the first, like 0 and the last address, both are reserved. First address is network address, last address is broadcast address. Means this way, in class C, total, there are 254 IPs, right? 254 IPs total. Means we cannot do networking of 300 computers if I go with class C. Got the point? Class C network means, and just it's a basic concept. Later on, I will tell you the trick, right? The trick to what? To do what? To increase or decrease number of IPs in any network. I'll tell you the trick, and that's not the trick, basically the concept known as subnetting. We'll discuss that later on, right? For now, without doing any manipulation, without doing any computation, in class C, there are total 254 valid IPs. Total 256, but out of 256, 2 IPs. Out of 256, 2 IPs, the first and the last cannot be used, cannot be assigned. And even like if you try to assign, so probably you'll get an error message, right? So even if I try to provide address, let's say if I just select this computer, and if I go to this config, fast Ethernet, static IP here, and I'm going to assign to 55, and the answer here, something error, right? Even if I try to assign 0, again error. Why? Because 0 and 255 both cannot be used. Yes, I can assign 1, no problem. Signed. I can assign up to 254. 254. Okay, 254. 192.168.1.254, no problem with 254. The moment I type 255 or 0, yes, there is a problem, right? So this way, I can like assign IPs to 254 computers, right? So you got like the idea, 254 computers. So if I am using class C network, means maximum 254 usable address. But my requirement is what? 300 IPs. So at least I cannot go with class C address, right? So either I can use class A or maybe class B address. Class B generally there are 65,534 IPs in one network, a very big network, and class is like bigger than B even. So you can understand this way for now that class A network is a very big network, class B a bit like small, and class C is very small network, only 254 computers. So this can be one of the criteria, one of the reason of selecting or choosing a specific class, right? And it's just like very a basic concept of IP addressing. So, but if your question is like, if now I have 4 computers, so should I use class C or can I use class B or A also? Yes, you are free. You can use A, B, or C, whatever class you want to use. Just go ahead, use that. No worries. They all are private IPs. Who cares? Like, you can do that. However, we understand like it's just wastage of IPs, but no problem. No problem whatsoever. Use that. Yes, if I have 300 computers, 500 computers, so my choice would be either A or B. At least C gone now. If I have, let's say, 70,000 computers, so my choice would be only A, because in class B, even 65,534 IPs, right? Beyond that, class A only. But I have 2 computers only, 2 IPs. My requirement is 2 IPs, 4 IPs. So all 3 classes are for me, A, B, C. I can use any class, right? In general. So this is one of the way like how we decide like what class of IP I should use with, I should use. And if I don't follow that rule, so you understand like what will happen. Let's say, uh, and already, let's say on third computers, if I assign IP here on this third computer, static IP, I assign like 192.168.2.5. No problem. But what I did, I changed the network portion. The third octet, look at the third octet, 2, 192.168.2, right? And here, 192.168.1 means it looks like they all are in the same network, but no, they are not. All 3 computers, just forget about the 4th one. Let me get rid of this 4th one, no problem. Oops. Okay, no issue. Even I deleted this, but no problem. Okay. So now there are 3 computers here, right? 3 computers, 1, 2, 3. So it looks like they all connected with the same switch, means a single network, right? But no, they all are not in single network. Like if IPs, like if you look at this IP address, so let's say IP address here is 192.168.1.192.168.2. So they both are in what? Different network, right? So whenever we define network, so we mainly focus at TCP IP address, because it's illusion in fact, right? Because all 3 computers connected with this switch. So from physical connectivity, it looks there is a single network, right? But might not be single network, or maybe a single network. So really, we don't always like look at the physical topology. What we care, IP address. Even there can be 3 different networks. They all can be in single network also, right? So they all can be in single network, and there can be 3 different networks, or maybe 2 computers in one network and the third one is different network. It's all about what? IP addressing, the network portion of IP address. Whether if network portion of all 3 IPs are same, so means they all are in the same network. Okay, so it's all about IP addressing. So network definition is based on what? IP addressing, right? Based on IPs, sorry, based on IP, what IPs we have assigned. So here, if like this machine, sorry, let me see, IP is 1.254, and this machine IP 1.254 and this 2.5. Now let's say this is also 2.6, for example, 2.6. So what I did, basically, there are two networks now, right? They both are in one network. Okay, they will communicate with each other without any gateway, without routing, without routing. They would communicate each other, right? And this machine is completely isolated. It's a separate network. So, and that's why just looking at the physical topology, we can never predict like whether there's a single network or multiple networks. In the same building, in the same room, there are three computers. Still, there are two networks. But why will I will do this? I mean, like there has to be a reason why you do this. Like why you do like segmentation. Of course not. Like three computers. No, there is no like way, no reason to create different networks. Of course, right? Because two computers are completely in one network. This one is another network. They will communicate with each other. This computer will not communicate with each other, and you can see this particularly as well. So if I just click here on this machine, if I go to desktop, if I go to command prompt, try to launch this ping command 192.168.2.5. No way, I cannot. Right? 2.5, no, not reachable at all. RTO request timed out. So this machine is not communicating with this computer, even though they both are connected with the same switch. Why? Because they both are very much a part of different networks. But I did intensely, you understand, I did all this intensely. You don't have to do all this, right? But in large network, like let's say I have a very large building of maybe 2,000 computers, right? 2,000 employees, a very big enterprise network. It's a LAN network, local area network. But what we do segmentation. We create multiple networks, right? And let me quickly put one good example here so that you can understand. Let's say in your network, basically what we do, and basically we put a device also, a firewall device, in fact, a security device. So we generally do like network segmentation or zoning, security zoning or network segmentation. We intensely create different network segments. For example, here, if let's say you have your database server, file server, some other servers, server farms, right? And here, like your users, laptop users, mobile, desktop, they all are sitting here, users, employees. And here, like you have maybe internet accessible servers accessible from internet side. And here, like you have your ERP servers, maybe database servers, some AD servers, some other servers. And this interface is internet. So this is a good design of network. Why? Let us assume if in this scenario, if these three servers are accessible from the internet, they are using public IPs, right? Website like example.com or something. So unknown users, like from the internet side, they are like hitting these servers, they are accessing websites and all this way, they're going this way. Let us assume like one of the server has got compromised, attacker or hacker compromised, attacked one of the server. Still, my other servers are still protected, right? My database server, ERP servers are here in different network segment, in different zone. So even if the server is compromised, so just going to these servers not allowed by this security device firewall. I mean, like lateral movement is not allowed, right? Even like users here from your internal networks, there is no free flow. In fact, even they are not freely communicating with these servers. No, they will have to go to this device, different network segments in the same building, right? In the same premises. But if we are doing this way, like we are doing network segmentation, zoning, so it's a best design because lateral movement is not allowed. Assume that you have not done any segmentation, right? Here is your network device, any device that provides internet connectivity, and in a same flat network, right? I'm using a term flat. A flat network means what? Your servers, your web servers, ERP, database servers, all servers, users here, servers, web servers, internet accessible servers, they all are in the same network, in the same network address. You have assigned IP address from the same range, class B address, a big network, right? What's the problem now? Big problem. It's not a good way of designing network. Why? Because if attacker, obviously, these three servers are accessible from the internet. You'll have to allow, right, from your network device, from firewall, access from internet side to these servers. Obviously, you're not permitting them to access your other servers, right? Because other servers means like holding, like some useful information like your customer mobile number, email address, your customer credit card numbers, US social security identifier numbers, and a lot of other confidential data. You never allow anyone to access those data, right? So you have just allowed these servers like example.com or abc.com. Now, if one of the server got compromised, attacked, now this free flow attack can be now launched to different servers. User can also attack these servers. They all are sitting in the same network zone. Not good, right? That's not good. Even there would be lateral movement. You have allowed lateral movement, right? Spyware or viruses or something that can also easily spread across like all the machines. Because like in beginning, like when you start your career as a network engineer, security engineer, so it looks very odd. In fact, why would I ever do like this kind of segmentation? I mean, like, why I would create multiple networks if all my computers are in the same building, in the same premises? So what you understand is like single network. But no, what we do, we create multiple networks, different network addresses. I mean, like IPs, maybe a different class IP, or maybe same class but different network addresses, zoning. We do everything, right? For security reason, for optimization, to minimize broadcast traffic, for better management, ease of administration, a lot of reasons. But we do that. So that's not the point, like that we would not create multiple networks, right? Because if you have, even like if you have 2000 computers, 5000 computers, and if you think that, okay, I'm going to use class B address and I will put all 5000 computers in single network, no, that's not best design. Forget about like accessing via internet and all that, forget that, right? Even from optimization point of view, not good, in fact, because if let's say a computer is generating some broadcast, and broadcast, you understand, one to all, unnecessarily that broadcast packet will hit other 4999 devices. Your network will get, like slow, very slow network. So even for optimization purpose, no, not recommended. You should not create a very big network. Do segmentation, create multiple networks. So for multiple networks, do we have to like isolate networks physically with each other? No. Physically, all 5000 computers will be connected. Either way, one switch to another switch, the third switch, fourth switch, fifth switch, rack of switches, do like as you wish. They all need to be connected physically. So how we do segmentation? Logical segmentation. And here your IP network portion plays important role. All right. So let me quickly jump to the presentation file first, and then I will take your questions, queries if you'd have any. And it's just like IP addressing only. It's not all about TCP/IP. In upcoming classes, we'll talk about subnet mask, subnetting, gateway concept, right? So if you remember, then we started with, let me quickly go through different slides. IP addressing. Already we have talked about IP address. Now you understand bit byte octet network address, broadcast address I explained in previous session. IP addressing, yes, you understand, like 32 bits address. Decimal representation 0 to 9, 4 octets. Octet means this one, separated with dot, right? Dot is separated. And IP address, there are two portions, network and host portion. Network address should be same in one network and host portion should be unique. Okay, so network address uniquely identifies each network. Every machine on the same network shares that network address as part of its IP address. And how many bits would represent network portion depends on class. Right? In class A, the first octet network bits. In class B, initial 2 octet. In class C, initial 3 octets define or represent network portion. Host means node address is assigned. So network, you can assume like network is like the locality, the area, and host address is something like house number, the number that you assign to identify each flats or houses in that locality, right? So host address is also known as node address, is assigned to and uniquely identifies each machine on a network. This part of address must be unique because it identifies a particular machine. True. Class A address. Now I hope you understand. So first octet 1 to 126. 0 is missing, 127 is missing. 0 is like reserved for a network address. We'll use this address in routing. 127 is again missing because it's a loopback address, again reserved. So in first octet, we start with 1 to 126, and in class B, we start with 128, right? 127 gone because reserved, that cannot be assigned to any computer machine. Loopback address, just for internal testing, troubleshooting purpose. In class A network address, the first byte, and you understand like byte means in binary, 8 bits. 8 bits is equal to 1 byte, right? So when we assign IP like 192, so it's a decimal, right? Its binary representation would be this. How I done this, I will let you know in maybe tomorrow's session, right? So we are writing down in decimal. We are assigning IP in decimal, right? 128 or maybe 192 or something. So we are writing down IP in decimal. But you understand, computer means understands zeros and ones, binary numbers, right? So we assign decimal values, but basically it's a binary representation. And if it is represented in binary, so this 192 would be 128, 64, and then 0. Like this. Maybe 193, then some different values like this. Right? 224 means like something different. So it's converted into binary number. So do we need to know like decimal to binary conversion? Yes, right? You should. But how is converted? I'll explain tomorrow. Or even you obviously you should know, but how well you can use your calculator also, like built in your operating system for this conversion. But this is not going to help you out like doing conversion this way. I mean, using calculator, no, that's not the way. So if you change the mode, not a standard, just select the which one programmer, right? So if I type decimal value here, let's say 192, and look at this conversion. So what I did, I typed in what decimal. See here, decimal 192, and it's binary representation. Decimal and binary is decimal 1100 and then 00. So even we have the calculator, we can easily convert this decimal number into binary, but you should also know how to do the conversion, and in both ways, decimal to binary and binary to decimal, right? For example, if let's say if you see any binary numbers, like let's say written this way, 1000, suppose, right? So it's like equivalent of 131. It's the binary number equivalent of 131. So but you should know like how like this is converted. I mean like if you hit down binary here and I'm writing here and see here, look at the option here. I selected binary, right? And on this pad, just see what you find here. Only 1 and 0 highlighted. Rest number grayed out. Why? Because in binary only 0 and 1s, right? Intelligent. Computer is of course intelligent. So now if I type here 1 0 0 0 4 and 5 0. Something wrong I typed. Let me clear this. So 1 and then now if it's just one, it's taking like a 4 only 1 0 0 0 this. And if you look at this decimal representation, so it is equivalent of 8, right? And if I just type this, let's say 0 0 1 0 and then again 0 0 1 1, so it's equivalent of 35, right? So how is all happening? And this way even like you can take any value here, right? And if I show you this, all ones, right, is equivalent to in decimal 255. And tomorrow you will understand like, so today we are using calculator, right? So 111 means like 255, but 255 means 1, but tomorrow, or maybe if I'll be able to spare out time today, so today itself, but probably not today, tomorrow, I will like tell you the logic, the way how binary to decimal or decimal to binary conversion is done. So if you are not knowing how to convert binary numbers to decimal or decimal to binary, so you'll understand tomorrow. And really it's very, very important, right? Because we are not going to use calculator anytime, no. We will be doing computation at our own without using any calculator, right? And you'll have to learn that. You'll have to understand the logic, and I will tell you how to do the conversion. Anyway, so first network portion 1 to 126, and if you look at the host portion, so any value between 0 to 255, but all zeros and all ones in binary means 0, everywhere 0 or everywhere 255 not allowed. So these two IPs not allowed, right? Okay, in class B, first octet, any number between this. But initial two octets represent network portion, right? And in the rest two, host portion. Again here, 00 or 255, 255, both addresses not allowed. Host portion 0.0, 0 and 0 here again, both 0 all at the same time, and both 255 at the same time, no, not allowed. Both are reserved network and broadcast address, right? And if you remember, so in class C, if you remember, so when I took the example of like 300 computers, so what I said that you can start assigning IP address from here 1.1, and you may go up to 254. You cannot assign 255, and you cannot assign the first address, right? These two addresses are reserved. Hence, in class C network, maximum there can be 254 valid usable IPs. Two IPs are excluded. Total, in fact, there are 256 IPs, but we are subtracting two IPs, first and the last. So total 254 IPs. Agreed? Only 254 IPs. All right. So let me go back to this presentation file. I already have shared this presentation file with you all guys, so you can refer that. Class C, 192 to 223. Any value between this range 192 to 233, but initial 3 octets network portion, last host portion 0 to 255, class C network. Class D multicast routing, however, the range starts from 224 to 239, and as such here, like there is no network ID and host ID in class D. Class E is for the research purpose, not for the use. So class A, B, and C are the only ranges that are used to address hosts in our networks. Means for unicast communication, unicast routing. And here is the list of reserved addresses. 127.0.0 or any IP starting with 127, loopback address, locally, used locally. All zeros in binary, decimal equivalent will also be 0, reserved network address. All ones in binary, but in decimal 255, again reserved as a broadcast address. Here it is, I'm sorry, this one. Entire IP address set to all ones. So all ones means broadcast address. All zeros at the node portion is network address, and node address of all ones in that specific network is like again broadcast for that network, and 0 is again for that network address only. I'll explain these two. Forget like for now. No need to be focused on this network address and all that, because you'll understand like network address concept once I start routing, right? Because very much like they are going to be used in routing, and basically the IPs are actually written this way: first IP, right? Second IP, third IP address, fourth IP in binary, right? Then the next IP, see here, like then further, then again. So IPs are written this way, right? In binary. This is what? Binary representation. And how many bits? 8 bits. Decimal value is 0, this is 1, this is 2, 3, 4, 5, 6, 7, right? This way. So we write down in configure IPs in decimal, but behind the scene is all binary, zeros and ones, and it's a 1 octet. Okay, 1 octet, 8 bits. So 1 octet or byte, one of the same thing, right? So 1 octet means this one. So numbers are written like this. So here, if I take any, like if you remember, so we talked about like 3 different classes. First octet is used to identify class of IP address. Second, third, and fourth octet in any class, right? In any class IP address, second, third, and fourth, these 3 octets can have any value between 0 to 255. But they all cannot have 000. They all cannot have 255, 255, 255 at the same time. That's not allowed. Like, all zeros and all ones not allowed. Tomorrow I will explain in binary how written, how converted, right? So tomorrow we'll understand that. So any question, guys, so far, like related with private IP, public IP, different classes, class A, B, C, identifying, assigning. So if any question, any doubt so far, so just go ahead, ask your question. And I think would not be, this would be too much if I just take another, if I start another module, I think this would be too much like to digest for a single class. So subnet mask is the next one. So if we sum up this, so we have finished class ABC addressing, rule, network and host portion, identifying class, in next session, in next class, means tomorrow, we will understand another important concept, and that is subnet mask. Because without subnet mask, just giving you a very high level overview, I'm not going to start that topic, and you understand the reason, like because uh, I don't want you guys to be confused, with IPs, mask, and all that. So I'm going in very phased manner at very slow pace. I'm not picking up, in fact, because really it's like very important, and you should understand. So whenever we assign IP address to maybe your physical adapter or Wi-Fi adapter, generally Wi-Fi adapter we go with the DSCP assigned. So IP address is not the only configuration that we do. No, IP address is not the only configuration, right? If here, if I just give here any address, let's say, and if I hit down tab key from my keyboard, or maybe if I click with the mouse and see here, look at this, the next portion, right? What is it? Subnet mask, right? So, and even I didn't mention any mask here. It's automatically auto-filled. How? And what's the use? And what is this 255.255.0? We'll understand that, right? But for now, you should understand IP address alone is not of any use. So this one is a very important part of IP configuration. Even you can leave this field blank, no problem. You can leave this field blank, this field blank. However, when gateway need to be specified, what is the role of DNS? I will explain that also. But even if I just hit down OK, then yes, IP address will be accepted, very much accepted. Will not give any warning, not give any error message, right? But without subnet mask, only IP address, no way. And see, look at the message here. You have entered an address that is missing is subnet mask. Please add a subnet mask. Even though if you don't understand the logic, you don't know what is subnet mask is, what value, what is the range, how I should what value I should fill here, no problem. Just click with the mouse or use tab key from your keyboard. This value will be auto filled, right? Auto filled, and that's what subnet mask is. And basically, if mentioned somewhere, this is the default mask here, right? Pre-decided based on class. So I used class C address, and the auto-filled mask is what? The same. Look at this, 255.255.255.0, right? Based on this, and look at this mask value. Can I change this? Yes, but why? I should know the reason. I should have the valid reason why I should change this subnet mask and when, what. Okay, but you'll understand. Later on, you will understand. But for now, both IPs and masks, both are important configuration of IP. IP address alone, only IP address is not of any use. And that is why if anywhere on computers, routers, firewalls, switches, anywhere, if you assign IP address without mask, nowhere like IP address will never be accepted. No, right? They go hand in hand. In fact, both IPs and masks, they both are important, really. Gateway, even you can skip if not required. DNS, you can skip, not required. Mask, no, you cannot skip. And I will explain tomorrow why and what's the use case, right? Just I'm canceling all this. So we have finished IP addressing, right? What we have not covered so far, binary to decimal conversion, decimal to binary conversion, subnet mask, subnetting. No, we have not done yet, right? We'll do that tomorrow, day after tomorrow. But at least I have finished IP addressing, class ABC, and very much like about a little bit about protocol, about MAC address, hardware address. If you remember in previous session, we talked about these addresses. And like once we have done with IP addressing, subnetting, subnet mask, then after I will introduce you to the routers, Cisco routers. Then probably we'll start doing labs also, lab session, right? Because once we have done with this, you understand like IP addressing. So we'll jump to the network device. At first network device, we'll start with this device, router, right? This one, router. So we'll start with this router, and in real like look is like this. If you look at physical device, so this is the a device. In fact, we'll be working on it device, and we'll do its configuration and command and all that. So it's very interesting, and see here. So I will introduce you to this device, and then like running commands like how to configure this router. So you would be very interesting there. You'll completely build a network. In fact, right? You'll be doing routing and all that stuff. So on this device also, like we assign IP. So like how IPs are assigned. So here also, if I just show you on this device also, how is a network device, and if so, the way like how IP is assigned is different way. So let's say if I say 72.16.1.1, enter, and see here, even router, this network device, what is router? Just like don't understand, no problem, no problem whatsoever. I will just make you understand. No worries, right? So, but what I want to show you, just like this IP address only. So even it's a network device, I tried to assign IP address to the like interface, like the same interface. Remember, I explained NIC card, Ethernet card. This device also has a NIC card. I tried to assign IP address, and what it's saying, incomplete command, right? And I hope you understand now why incomplete command. Why incomplete command? Where is mask? IP address without subnet mask, incomplete. And since we are doing configuration from CLI, command line interface, so here I cannot use tab key from my keyboard for subnet mask configuration. I cannot click from my mouse, right? Now I'll have to know the subnet mask concept. Okay, I'll have to know that. I'll have to type here. Even if I try to take help, so it's going to give the help, and what it is telling me, please specify mask here. If I say yes, I know like what would be the mask, enter and done, accepted now. IP is assigned now, right? IP is assigned. And see here, IP address is assigned to this device. Even the protocol is down, interface is down, I'll bring it up, but IP address is assigned here. So what I did, I just assigned both IP and mask. So we'll understand like the whole concept. I will introduce this router, and I will start from the scratch from the very beginning. What this device is, why we would use this device in the network, what is the use case, how to start doing configuration, CLI. But yes, then after I believe your training would be more interesting, because then every day you will have to perform some task. You'll be doing lab. In fact, you'll be building topology. You'll maybe I will give you some like some assignment. In fact, to do in your off days. I mean like if we are having sessions on Monday, Tuesday, Wednesday, 3 days. So if you are not able to spare out time, then maybe probably on weekends, Saturday, Sunday, or in any free time, yes, like you can do your lab practice, and I will show you like, and even I will suggest you how to start doing lab practice. And then probably like this would be the most interesting section, in fact, like because theory and as well as lab would be more beneficial. And that is why I'm not uh, like picking up very fast, because 2 hours theory class means like too much, too much to understand, right? So I'm not in hurry. No rush. Learn at your own pace. All right, guys. So, any question, guys? So you can ask because I will end up today's session here. I will wrap up today's session. We'll continue from tomorrow. The subnet mask. So I just showed you like the where you find that option subnet mask on computers or maybe network devices. But what is subnet mask? I will explain that tomorrow, not today. All good, guys, so far? Still some confusion.
All good on my side.
Okay.
Yeah,
Jai, good?
Yep,
Good so
very
far?
good. Yeah.
Other guys, you all like understood something like about IPs? I understand like you need a revision, right? You need revision. You'll have to probably would go through this recorded session one more time whenever you get free time. So you should definitely revise, like you should watch recorded session because concept is really very important. Understanding networking, security, cloud, cyber security. In the beginning also, as I mentioned, understanding TCP/IP is very important, no matter in which domain you want to get into. But TCP/IP or basic networking is the backbone. Is the backbone. So there is no other way around. I mean, like you'll have to understand that anyhow. Like either just spend good amount of time, ask me to repeat that session. I don't mind even, right? So if you are unable to understand something properly, ask me. I will repeat that session. I will take the same lecture again, no problem. But you'll have to understand, like no way to giving it up. So you'll have to understand TCP/IP all the way. All right, guys. So next class would be tomorrow. So same time, same meeting ID, password. All right. So in this week, we would have 3 classes. Today already we have done with 2 more classes to follow. And probably we would finish like TCP/IP in this week. From next week, then we'll start some lab session. Then this tool would be required, then packet tracer. So maybe in this week not required to like very much like this packet tracer, but from next week, once like I introduce routers, I just started doing basic configuration, then definitely you will have to install this tool packet tracer on your laptop or desktop also, so that you can also do your lab practices. Okay. So I'm also stopping my recording and we will now start tomorrow.